Good morning to all of you. My today presentation topic is the principle of metallurgy and chemistry of iron, copper, nickel, uranium, gold and silver. Minerals. Metals occur in nature, sometimes free but mostly in combined state. Those found in free or in native state are copper, mercury, silver, gold and lead. The metals are found in the combined state with other elements and are obtained by mining from the earth are known as minerals. Copper minerals are oxides ores Cu2O, CuCO3, CuOH twice. Sulfide minerals are Cu2S, CuFeS2 etc. Ores. When a minerals contain sufficient quantity of a metals combined with other elements from which it can be radially separated so as to render the extraction of metal of good quality probable, it is said to be an ore of metals. All ores are minerals, but all minerals are not ores. That is Fe, Fe2O3.3H2O hematite, Al, Al2O3.3H2O bauxites, U3O8 pitch blends, gangue or matrix. The ore usually contain a large number of impurities like earth matters, rock stones, sand, limestones, mica and other silicates. These impurities are known as gangue or matrix. The ores are divided into four groups: native ores or the free state. The less reactive metals like the copper, silver, gold, platinum, mercury and lead occur in the free state. These metals are known as native ores. Oxides ore. The ores are classified as oxides and hydroxides. The metals like copper, zinc, lead, aluminium, tin, chromium, manganese, vanadium, iron, manganese, beryllium, etc. occur as oxides and hydroxides. That is Fe2O3.3H2 hematite, CuCO3.CuOH twice malachite. Carbonates. The metals like the iron, copper, zinc, lead, manganese, calcium, strontium, barium, manganese, etc. occur as carbonates or that is MgCO3 dolomite, CaCO3.MgCO3. Sulfates. The metals like strontium, calcium, barium, etc. occur as sulfates ores. Calcium, gypsum, CaSO4.2H2O. Silicates. The metals like the copper, zinc, nickel, aluminium, beryllium, etc. occur as silicates. Beryllium, beryl 3Bo. Al2O3.6SiO3. Phosphates ore. The metals like the calcium, strontium, are etc. as phosphate ores. Calcium rock phosphate, CaPO4 twice. Sulfide and arsenides ore. The metals like copper, zinc, iron, cobalt, nickel, lead and silver etc. occur as sulfides and arsenides ores. That is CuFeS2 copper pyrites, nickel, copper, iron, sulfur, pitch blends. Halides ores, including chlorides and oxychlorides metals like sodium, potassium, magnesium, silver, etc. are obtained as chlorides and oxychlorides. Sodium, common salt NaCl, calcium, carnallite, KCl.MgCl2.6H2O. Nitrate ore. The metal like the sodium, potassium, etc. occur in form of nitrate ore. That is sodium, chili saltpeter, NaNO3. Metallurgy. It is the branch of science dealing with the method of extraction of metals from their ores and preparation of alloys. Generally, few methods are used for isolation or extraction of metals, ore dressing or concentration of ore. The ore usually contain large quantity of impurities like earthy matters, rock stones, mica, feldspar, etc., which is known as gangue or matrix. Removal of these impurities from ore is called as ore dressing or concentration of ore. During ore dressing, the percentage of metal increase, so it is known as concentration. The purified ore is known as concentrate. The operations carried out during ore dressing are as follow. Hand picking. The ores can be separated by sufficient degree of purity by simply picking it by hand and breaking the rock stone with hammers. The specific gravity. The ores is crushed in jacqueries and powdered in ball mills. If the ore and gangue have different specific gravity and if the ore is lighter and gangue is heavier, then it is concentrated by gravity separation. In this method, the powdered ore falls on jerky sloppy tables and the stream of water is passed. So the ore is flown away with stream of water and impurities fall below table from where it is removed. Magnetic separation. This method is used when ore and gangue having same specific gravity but one is magnetic and other is non-magnetic, that is ore is magnetic and gangue is non-magnetic. A thin layer of powdered ore is allowed to fall on a rubber belt which moves horizontally and then passes over a pulley, a magnetic field. Gangue particles or the particles of a non-magnetic minerals falls off as the belt becomes vertical. The magnetic particles are retained on the belt until they pass out of the influence of the magnet. Magnetic separation. Froth flotation process. This process depends upon the fact that certain minerals are wetted by oil while gangue is wetted by water. Mainly this process is used for the concentration of sulfide ore of copper, lead, zinc, mercury, etc. The grounded powder ore is taken into a big tank. To this a mixture of water and small quantity of terpenoids oil or pine oils and suitable additive Na2CO3 is added. Then compressed air is passed so the whole mixture is agitated violently and froth is produced. The ore particles stick to the oil particles and come out on the surface as foam and it is collected. The impurities like earthy matters, rock stones, limestones, mica, etc. are weighted by water, become heavier and settle down at the bottom of the tank. By using this process, the sulfides ore of copper, zinc and lead are separated from the impurities. Froth flotation process. Calcination and roasting. For chemical reduction, the concentrated ore is converted into oxides by calcination and roasting. Calcination. It is the process of heating the ore at low temperature in the absence or any blast of air. The moistures CO2 etc. are removed and the ore becomes porous. That is when limestone is heated, CO2 is given off and it is said to be calcinated. When bauxite is calcinated at high temperature, water is removed and anhydrous aluminium is left. CaCO3 when heat, calcium oxide plus CO2, Al2O3.2H2O, Al2O3 plus 2H2O. Roasting. It is a process of heating of the ore strongly in excess of air. The roasting includes the following types. Oxidizing roasting. The volatile impurities like sulfur, lithium sulfide, antimony are removed as volatile. It is used for CuFeS2, ZnS, etc. Blast roasting. The blast of hot air is passed through the ore for the expulsion of the sulfur and metal is converted into oxides. This method is used for galena and copper pyrites. Chloridizing roasting. It means the conversion of a metal of ore into a chloride by heating with common salt in presence of air. Silver is converted to AgCl and then amalgamated for the extraction of the metal silver. Sulfating roasting. It is partially oxidizing roasting in which a sulfate is not converted to an oxides but soluble sulfate, that is copper sulfide to copper sulfate. These soluble salts are taken out with water and used for further treatment. Calcination and roasting are carried out in reverberatory furnace. Sometimes kilns are also used. Smelting. It is general term used for various operations whereby the metal is separated by fusion from the ore. Chemical reduction by using powerful reducing agent for the extraction of rather less electropositive metal. Powerful reducing agent such as H2CO, water gas H2 plus CO, sodium, potassium, beryllium, aluminium, magnesium may be used. Chromium and manganese are obtained by reduction of their oxides by aluminium powder. This method is known as gold-schemidt aluminothermic process. A mixture of metallic oxide and aluminium powder is known as thermite and hence this process is also called thermite process. Cr2O3 plus 2Al give 2Cr plus Al2O3. 3Mn3O4 plus 8Al give N9Mn plus 4Al2O3. Carbon reduction process. The oxides of less electropositive metals like lead, zinc, copper, tin, etc. are reduced by heating them with coal or coke. Zinc oxide plus carbon gives Zn plus CO. PbO plus C give Pb plus CO. Flux and slag. In order to remove infusible impurities, a suitable substance known as flux is added during reduction process to convert infusible impurities to fusible materials, which is known as slag. The slag is lighter than molten metals, hence it floats over metal and is removed from the slag hole. Ore plus gangue plus reducing agent plus flux plus heat give metal plus slag plus gases. The nature of the flux used depends on the nature of the impurities to be removed. An acidic flux is used to remove basic impurity, FeO basic impurity plus SiO2. Acidic flux gives FeSiO3 fusible slag. A basic flux is used to remove acidic impurities, SiO2 impurities plus calcium oxide. Basic flux gives CaSiO3 fusible slag. Some ores are self-fluxing because they contain some gangue which is itself fusible and no foreign flux is required. A reduction. This process is applicable to the extraction of less electropositive metals, may be reduced without using any additional reducing agent. Higher temperature and anion presence with metal bring this change. That is, cinnabar HgS is roasted in air until a part is converted to oxides HgO. On further heating, in the absence of the air, the oxides reacts with the unchanged HgS to give Hg. 2HgS plus 3O2 gives 2HgO plus 2SO2. 2HgO plus HgS gives 3Hg plus SO2. This process is called autoreductions. Electrolytic reductions. When the oxides of highly electropositive metals like alkali metals, alkaline earth metals, aluminium, etc. are heated with carbon at high temperatures, the metals combine with carbon and form carbide. These metals are extracted by electrolysis of their oxides, hydroxides, and chlorides in fused state. Some other salts may be used to lower the melting points of the compound under electrolysis. The additions of the salts help in electrolysis in following way. To lower the vapor pressure of the metals, it reduces the corrosion troubles. For example, in manufacture of the sodium by electrolysis of fused mixture of NaCl and CaCl2, the reactions are as under. On fusion, NaCl dissociate into Na positive plus Cl negative. On electrolysis at cathode, Na positive plus electrons converted into sodium. At anode, Cl negative while losing electrons converted into Cls. Cl is unstable species. It combines with another species to form Cl2 gas. Refining or purification of metals. The metals obtained after smelting contain greater or lesser amount of impurities. These impure metals are purified by various ways. First is distillation, second liquidation, third sublimation, fourth electrolysis. Furnace. The principal type of furnace used in metallurgy are as follow: reverberatory furnace, blast furnace, open hearth furnace, muffle furnace, electric furnace, kilns. Reverberatory furnace. In this furnace, the fuel is burnt in a separate part of the furnace which is known as fireplace. The fireplace is closed at the bottom of iron bars on which the fuel is placed and burnt. The rest of the horizontal part is known as hearth or bed. The roof of the furnace is concave and takes bent towards the end away from the fireplace and communicates with the chimney. The charge is placed on the hearth and fuel is burnt on the fireplace, so the hot gases and flames are deflected towards the hearth by the concave roof. Thus the charge is heated and it will not come in direct contact with the fuel. Since the fuel does not come in direct contact with the charge, the reverberatory furnace can be used for reductions as well oxidation process. For reductions, the material is mixed with reducing agents like coke and carbon, while for oxidation it is heated in a current of air. The calcination and roasting are carried out in this furnace. Blast furnace. It has characteristic shape. It is about 30 meter in height and 6 to 9 meter in diameters. It is made up of steel plates. it is lined inside with fire clay bricks. The hearth may be lined with carbon blocks for durability. On the top of this furnace is cup, cone and hopper system, though which charge is introduced in the furnace. Air heated at 550 to 850 degrees Celsius by combination of waste gases is blown under pressure through tires or nozzles. The downcoming charge meets the upward moving hot air blast. The temperature at tires is 1500 degrees Celsius and at top is 200 to 300 degrees Celsius. The product leaves from three places. First, the molten iron is tapped from the base of the hearth every 6 hours or so. Second, the less dense molten fusible slag floating on the molten iron is tapped more frequently through separate outlet. Third, waste gases escape through the exit near the top. These gases are purified before combustion. Blast furnace is mainly used for manufacturing of cast iron. Open hearth furnace. This furnace is used for the manufacture of steel and works on the regenerative principle of heat economy. This furnace is known as Simon-Martin furnace. The furnace is heated by producer gas burning in the furnace over the hearth. The hot producer gas passes out from the other sides of the furnace. In actual practice, the hot gases are made to pass through a brick chamber and then the incoming cold gases are preheated by first passing through this chamber. In the regenerative system, the heat carried away by the fuel gases is not allowed to be wasted. The hot fuel gases are passed through bricks chamber which gets heated and the gases going out of this chamber are at much lower temperature. After some time, fuel gases are passed through this hot chamber and the fuel gases are made to heat another brick chamber. The fuel gases preheated in the chamber burns and supplies more heat. After some time, the currents are again reversed. Refractive materials. These are the substances which can bear very high temperature without melting or becoming softer. A suitable refractive materials bears following properties. These type of substances do not melt or soften to an appreciable extent upon exposure to intense heat. They resist sudden and great extreme temperature. They support considerable pressure at high temperature without crumbling. They resist corrosion of slag. Refractory metals are used in the form of bricks for the internal lining of the materials, flush and hotter parts of the chimney. The commonly used refractory materials according to their acidic and basic nature are as follow. Silica in the form of ginsters, quartz, sandstone, etc., which are acidic. Fire clays consisting of 50 to 65% SiO2 and 22 to 35% of alumina. Semi-neutrals: graphite, chromites, bone ash neutrals, lime dolomite, manganese basic. SiO2 and kaolin resist temperature up to 1740 degrees Celsius. Bauxite bricks up to 1800 degrees Celsius, alumina up to 2000 degrees Celsius, and magnesia and chromite bricks up to 20 degrees Celsius. Graphite is one of the most valuable materials for manufacturing of the furnace. Zirconia ZrO2 is one of the most refractory substance yet known and would up to 2600 degrees Celsius unchanged. Thank you.